Hello and welcome. In this video I'm explaining something to myself because I needed this explanation a long time ago in my life when it was a time, but nobody seems to care about this to explain it to me, so I'm answering it myself. This is not a very typical question or something else, something hidden, some great concept, just answering myself. And we all know that if a block is left to block is released from rest from this position, a height 5 by 2 or above, where r is the radius of this dead loop, and so that this is the minimum height required, so that if the block will fall from this height 2.5 times the radius of this dead loop, then it can continuously move in the loop without breaking anywhere except at this point, because for the minimum normal will be 0 at this point only, and rest of the point normal will not be equal to 0. It wondered me, it amused me how. And I wanted the answer to this question, but nobody explained me, so I'm going to explain it to myself today. And I'm making a video because I have the privilege to make a video on YouTube, so I'm going to make a video for myself. I would like to take this block at this position, not here, not exactly here, at this position, at some angle alpha, from with the vertical, and so that let the mass of the block be m, so that if this angle is alpha, the gravity will be acting on it in the vertically downward direction, and its value will be equal to mg, and the normal force will also act in this direction, so that the expression for its centripetal acceleration can be written as n plus mg cos alpha, and that will be equal to mv square by r. या ऐसे लिख सकते हैं. ऐसे लिखने के बाद I can go one step further and I can write n equals mv square by r minus mg cos alpha. And so I would like to get the velocity v here. So I'm willing to use the principle of conservation of mechanical energy. So I should have information about velocity of this block at any other point, and I know here when it comes down right away from here to here, its velocity will be horizontal, and its velocity will be simply at under root 2gh, that means under root 2g 5 by 2r, and that I get it will be 5gr. The velocity, the value of this, the velocity magnitude at this moment, at this point, and so that I can find the velocity, value of velocity here by using mechanical energy conservation, and it's simply v square equals u square minus 2g into height, and this height, I suppose this height is going to be r plus r cos alpha. So this is simply v square equals u square minus 2g r plus r cos alpha. Yeah, that's right. And u square, the value of u square becomes simply 5gr. So I'm going to put it down here. The equation becomes 5gr minus 2gr 1 plus cos alpha. And I put this v square in this expression, where I got n equals mv square by r minus mg cos alpha. if I put these values, I simply get b square 5gr. R get cancelled out, so the first term I get is 5 mgr, 5 mg only, because r gets cancelled, and next term will be 2 mg 1 plus cos alpha, and again there is a mg cos alpha already here. So finally I get 5 mg minus 2 mg minus 2 mg cos alpha minus mg cos alpha, so that the right hand side of it becomes 3 mg 1 minus cos alpha. Yeah, that's right, 3 mg 1 minus cos alpha. This is the value of n under the circumstances, and you can see here that if alpha is equal to 0, then normal is 0. Otherwise, and alpha here lies between 0 to pi by 2. So that from top to bottom, alpha lies between 0 to pi by 2. Otherwise, after pi by 2, normal can't be 0. After this horizontal position, normal cannot be 0. So between 0 to alpha, this is the only position where normal can be 0 and not anywhere else. So this satisfies the condition, and I answered it myself. Thank you very much. If you watch this, wondering what was the question again, and it will say you there is nothing like a question in here. It was an explanation of something that came between problem solving. Thank you very much.